This is the video for 3.2. If you want to pause the video and get the vocab, you can certainly do that. I'm going to talk through a couple things. So this picture goes for all four. This picture goes for all four. So what this setup is called is this is two parallel lines. Those are marked with the arrows going the same direction. That's how we know for sure that they're parallel. And then this other line is called the transversal. We learned that from 3.1. So this picture, this setup, is called two parallel lines cut by a transversal. It just means the transversal is going through both of those lines and the lines happen to be parallel. When that happens, we get those 8 angles. And we learned about the names of these angles yesterday in 3.1. We had corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. Now, when lines are parallel, cut by a transversal, these angle pairs have special relationships. And so for the definition, you guys, every definition has this sentence to start. So I just wrote it one time, and then these are what follow. So when two parallel lines are cut by a transversal, corresponding angles are always congruent. So from this picture, I listed every pair of corresponding angles. They are always congruent when the lines are parallel. And here's the abbreviation for that statement. So corresponding angles postulate means that if lines are parallel, I know that corresponding angles are congruent. Just corresponding angles are just the name of them. The postulate is what tells me it's congruent. Alternate interior angles, this is a theorem, but they are also congruent when I have parallel lines cut by transversal. So I've got 3 and 6 and 4 and 5. Alternate exterior angles are congruent, so 1 and 8, 2 and 7. So all those 3 pairs are congruent when we have parallel lines. The only ones that are not are same side interiors. So 3 and 5, they're not congruent. Instead, they're supplementary. So angle 3 plus angle 5 adds to 180, and angle 4 plus angle 6 adds to 180. So we're going to use those new theorems and postulates to do some problems here. Get that to focus. There we go. Okay, so this first one says, find the value of x. So right away, I noticed these lines are parallel. So when that happens, all those different theorems and postulates are happening. All those angle pairs are either congruent or supplementary. So then the thing I want to look at, if I have to find x, so I've got these 2 angles that involve x. So I'm going to set up an equation that involves that. Now I need to identify what kind of angles these are. Are they corresponding, alternate interior, alternate exterior, or same side interior? These are same side interior. They're the same side of the transversal, and they're in between the parallel lines. So the relationship between same side interior angles is that they are supplementary. So I'm going to add these 2 angles and set it equal to 180. So we've got 36x equals 180. Divide by 36. And we get x equals, gets 5, but let me check on my calculator here. So we've got 180 divided by 36. Yep, it is 5. So that is our value for x. They didn't say prove or anything here, just said find x. Now this next one asked me to prove. So I'm going to set up a t-chart. Here's my statements and reasons. Okay, and I'm actually going to add a couple points in here, you guys, just so talking about these angles is a little bit easier. DEF, let's go G, point up here, and we'll put H over here. So then I can talk about that top angle and this angle here. So we're trying to prove that x equals 6 and -5. So notice there's 2 solutions here. And if I were to plug those in, well, I guess we'll come back to that. So I noticed right away that I have a quadratic because I have an x squared, so we're likely going to get 2 solutions. So first, all of those angle pairs happen when we have parallel lines. So I'm going to say that's my given, that DH is parallel to EF, and that's given in the picture. I'm also given that these are angle measures. You can add that if you want as well. So the next thing I want to do is I want to set up an equation because I have to find the value of x. That's got to be my last statement. So here, I want to say what's true about these 2 angles? Well, what kind of angles are these? This angle and this angle are corresponding angles. I know that when I have parallel lines, corresponding angles are congruent. So I'm going to say the angle GDH is congruent to angle, and actually I'm just going to skip this step, you guys. I'm going to jump right to the equation. I'm going to go straight to saying that x squared is equal to x plus 30, and my reason is the corresponding angles postulate. Those are corresponding angles, meaning they're congruent, so their measurements have to be equal. Okay, so now I'm trying to solve this for x. So again, we see it's a quadratic, so I'm going to subtract x to the other side and subtract 30 to the other side. So we're using the subtraction property of equality. And I'm going to write that in standard form now. So I've got x squared minus x minus 30 equals 0 when I simplify. And now I'm going to factor, so numbers that multiply to be negative 30 that add up to be negative 1 would be negative 6 and positive 5. So we just factored there. Okay, so remember, once it's factored, now I can set each factor equal to 0. So x minus 6 equals 0 is one equation. X plus 5 equals 0 is the other. That is the 0 product property. All right, and now in solving these, so I'm adding 6 to both sides on this one, and I'm subtracting 5, so I'm using both the addition and subtraction POEs. So we're left with x equals 6 and x equals negative 5 when we simplify. And remember, whatever I'm trying to prove is what my last line should be. So that is my last step. Okay. This one says, prove the alternate interior angle theorem without using any of the new theorems. So this is kind of a play on words. If you notice, all of the ones that were not, or that were theorems, there's one that was not. So corresponding angles was a postulate, so we can use that one. So we're going to try, let's give a picture here. So we're going to give our two parallel lines cut by a transversal. I guess we'll set up our 8 angles here. Okay, so, and then we're given these are parallel. We'll call these A and B. Okay, so we are given that A is parallel to B, and we are trying to prove the alternate interior angle theorem. So I want to prove that a pair of alternate interior angles are congruent. So I'm just going to pick a pair. Let's prove that angle 3 is congruent to angle 6. Okay, so I cannot use a theorem. So I can only, or sorry, a new theorem. So I can't use AIA, AEA, or SEA. Okay, so these are AIA, AEA, or SSIA. So we cannot use these. Okay, so the ones I can use, I have corresponding angles postulate. I also have linear pair and vertical angles that I could potentially use. So okay, so here's my given. Okay, so I'm given these are parallel. I want to do something with 3 and 6. I can't use any of these. So I want to use something besides that. So I need another angle that connects 3 to 6. And it cannot be one of these. So the one that I'm kind of thinking right now is maybe angle 2. So angle 2 is vertical with angle 3, and it's corresponding with angle 6. Those are ones I'm allowed to use. So I'm going to use 2 as kind of my middleman. So angle 3 is congruent to angle 2 by the vertical angles theorem. Okay, now I'm going to make a connection with angle 2 and angle 6. So angle 6 is congruent to angle 2 because of the corresponding angles postulate. So if angle 2 is the same as 3, and angle 2 is also the same as angle 6, angle 3 must be congruent to angle 6, and that is the transitive property. If something is congruent to two different things, those two things must be congruent to each other as well. Okay, so we just did it. We tried to prove angle 3 is congruent to angle 6. We're done. All right, and that is it for 3.2.